Hi, my name is Tang. I'm a student of Curtin University and studying Bachelor of Information Technology in Computer System and Networking. This is the second video in my project. Basically, the information from a plantation will be captured the temperature and humidity, both of air and soil. Based on those data, the system will decide the right amount and when the plantation should receive the heat and water. Also, the project should allow the manual intervention of an operator in order to control the water pump and electric lamp to generate the heat for the plantation. The manual intervention must be both local and remote via the internet. There are 5 steps to install the hardware in my smart weather system. Specifically, step 1, installing the OLD. Step 2, capturing the temperature and humidity. Step 3, capturing soil moisture. Step 4, completing the hardware. Step 5, the sensor red button. In order to verify the collected data locally, a small OLED display should be installed and using ESP1306, a robot library version. The model used on the system is the OLED 128 plus 64 SSD1306 I2C. We will use 8 plus 8 character to get 8 lines of 16 character display. This is an I2C display, so we will connect it to the non-MCU I2C pins. Using SCL connector pin D1, SDA connector pin D2, and it powered with 5V external. One of the most used sensors for capturing the weather data is the DXT11, which is a digital relative humidity and temperature sensor. It uses a capacitive humidity sensor and thermistor to measure the surrounding air and slips out a digital signal on the data pin. DXT11 has 4 pins. Pin 1 is VCC will connect to the 3.3V from the non-MCU. Because the distance from the sensor to the non-MCU is less than 20 meters, a 10K resistor should be connected between them. Pin 2 is data out. We connect to the pin D3. By using the DXT sensor library, we can output the data from the DXT11 to the display. The LM393 module has 2 outputs. One digital D0 that can be set up using the potentiometer that it is on, and an analog output A0. These modules can be shot with 3.3V, which is very convenient when working with the non-MCU. Pin A0 output to A0 non-MCU input. VCC to non-MCU VCC. It is important to highlight that the correctness to connect the sensor VCC to digital pins as an output. So the LM393 will be powered only when we need it. This is important not only to set the power, but also to protect the platform operation. Verify that on air temperature, humidity, and soil moisture sensor as the OLED are powered using the external 5V. The non-MCU is used only to provide control signals. Remember that using the non-MCU 3.3V external pins to provide power that can turn the system unstable due to the current switching. Note that LEDs connected to non-MCU are for testing only. They will simulate the pump for the red LED and the lamp for the green LED. For the final circuit, the relays will connect it to those output. Based on the reading of sensor, an operator could be also designed manually control. For the first button will be incorporated to the project. Red button is for manual control. Green buttons for alarm manual control. Yellow one for the sensor red button.